Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 49. Group Anagrams. This is a fundamental hashing challenge that tests your ability to identify patterns and choose the right data structures. Let us look at the problem statement. Given an array of strings, we need to group the anagrams together. Anagrams are words that contain the exact same characters, just in a different order. For example, eat, t, and ate all consist of one e, and one t. Our goal is to return a list of these groups. The trick is to find a unique signature for each group of anagrams. If two words are anagrams, they will have the identical count for every character from A to Z. Think of it like a library sorting system. Every book has a secret code based on the number of letters it contains. You do not care about the title, just the letter count. All books with the same code go into the same bucket. In our code, that bucket is a hash map where the key is a character frequency array. Let us dive into the dry run. Look at the screen. We have our input array at the top, and our hash map on the right. First, we look at eat. We count its letters. One e, and one t. This forms our unique key. We check our map, it is empty. So, we create a new entry with this key, and add e to the list. Next is t. We count the letters, one e, and one t. Wait. This matches our first key exactly. We go to that same bucket in the map, and append t. Now that group has two words. Now for tan. One n, and one t. This is a new signature. We create a second bucket in our map and place tan inside. We continue this for 8. Nat, and bat. 8 matches the first bucket. Nat matches the second, and bat creates a brand new third bucket. Finally, we simply return all the values from our map as our grouped anagrams. Simple, efficient, and effective. Now, let us look at the Python code. We start by initializing a default dictive lists called ans. This saves us from checking if a key exists before appending. We loop through every string in our input array. For each string, we create a count array of 26 zeros, representing each letter from A to Z. Then, for every character in the string, we calculate its index by subtracting the ASCII value of A from the character's ASCII value. We increment that index in our count array. Because a list cannot be a hash map key, we convert our count array into a tuple. We then append the original string to the list associated with that tuple key. Finally, we return the values of our ANS dictionary. This gives us the group lists we need. Looking at the complexity, the time complexity is O of n times k, where n is the number of strings, and k is the maximum length of a string. This is because we iterate through every character of every word once. The space complexity? It is also O of n times k, as we store every character of every word in our hash map. This is the optimal approach for this problem. And that is Group Anagrams, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.